Here we have 3 rotating stars. They have a mass allocated at the verticals of an equilateral triangle with side of 7,600 km. At what speed must they move if they all revolve under the influence of one another gravitational force in a circular orbit circumscribing the triangle while still preserving the equilateral triangle? So the idea, basically, we have to find the speed at which they keep the position of the triangle, okay? So how can we find it, that one? I think before finding it, first of all, we have to draw. This will be the center, okay? In order to preserve that one, there should be some conditions. The condition is that this is the centripetal force, okay? That centripetal force has to be equal to the force that due to the F1 force. This is F2 force. So that means the combination of two forces should be F net. Okay, this is the condition. So that means F centripetal has to be equal to the F net force due to the F1 and F2. Okay. F centripetal is very easy, which is equal to the mass velocity squared divided by the radius. Okay. Now the F net is a combination of F1 and F2. So how can we find F net force? Before finding F net force, let's find the F1 force. Okay. F1 force is equal to the, since masses are the same, so the m's are the same. Okay. That means F1 is equal to the G M1 or M2, so let's make it MM, divided by the length squared. Okay, this L is also given. So that is also equal to the F2, which is also equal to the G. Let's make it straight away M squared divided by L squared. Okay, since they are at the same, located at the same distance and it has the same mass. Now, since we know F1 and F2, how can we find this force? So that force, so let me say that if it's F1, then we can say Fx1, okay? What will be the angle? Angle here will be 30 degree, okay? And this is also 30 degree. That means we can say that F1x is equal to the F1 cos 30 degree, right? So that means we can say that, which is also equal to the, now F1, F2x is equal to the F2 cos 30. So that means our F net will be 2 times of the F cosine 30, okay? So we can say F1 cos 30 plus F2 cos 30, okay? Or we can say that, so let's bring it here. Let's bring it here, so we will end up with 2F cos 30 degree. Now our F is equal to the 2 times gm squared L squared cos 30 degree. Okay. Now we know that this is our radius. Right, this is our radius. Now the radius is equal to what? The radius is equal, if you do the mass calculation, you will find that our radius is equal to the L divided by the square root of 3. Okay, so let's continue. Our F centripetal was equal to the mv squared over r is equal to the 2g m squared divided by the L squared. Now the cosine 30 is equal to what? If you look at the table, is equal to the just let me just have a look. So cosine 30 is equal square root of 3 divided by 2. So 2 cancels out, so we'll end up with gm. So let's also cancel the m, so we'll end up with 2. Okay, so 2 cancel, gm and square root of 3 divided by the L squared, okay, which is equal to the v squared over r. What is left? Then this is what we got it now. So then we know that from here that our r is equal to that value, right? Okay, so let's continue. G m square root of 3 divided by the L squared is equal to the v squared. Now r is equal to the L over square root of 3. Okay, now square root of 3 goes up, so then it will cancel with this square root of 3. Then L will cancel 1 L here, so finally we will get g m over L is equal to the v squared. So that's it. So the final formula will be v is equal g m over L under the square root. So this is our final formula.